excellent connection, it says. I'm live. Okay. Okay, here we go. Wow. And we're live. And we're live. Cool. Concurrent viewers. Neato. Neat. Where's my chat? There it is. Hey. Hey. How's it going, everybody? Wow. So this is cool. That's what we want. All right. Let's get the little ye old live stream. And we've got our organizing containers of balls here. And you can see all the goodies. All right. Let's also do this. Okay. Cool. So to return to this question, now this is an interesting question. I thought about it some more after I went to bed, or when I was going to bed, and I realized something, and that is this problem is actually a lot easier, I think, than I realized. And there's a lot of different sort of classes. There's a few different classes of problems that these interview questions fall into. And in particular, this one, there's a certain sort of set of problems that they're relatively easy to solve using hash maps, frequency. Actually, not just hash maps, but frequencies, frequency maps they call them. So basically, you count how many of a certain thing occurs, and in this instance, you're going to use a frequency map of how many red balls there are, how many green balls, how many blue balls, we'll say, right? If we just color them instead of giving them type numbers. You count the frequency of those, and you also count how many balls are in a certain container. So how many balls how many containers have 3 balls, how many containers have 2 balls, how many containers have a certain number of balls. And you actually also want, you don't just want the number of red balls, green balls, blue balls, you want the number of times you have you have X balls. In other words, if you have 5 red balls and 5 green balls, you say you have 2 times you see 5 balls. And similarly with your containers, if you see a container that has 5 balls and another container that has 5 balls, you say 2 times you see 5 balls. And those two numbers, or rather those numbers are the ones you're going to compute in one pass through the values. And then what you want to check is that all those two hash maps, those frequency maps that you've computed, are equivalent. They have the same value, same keys and same values attach those keys. And that's this whole problem. That's it. That's all you have to do. It's very straightforward once you see it. But yeah, there's a certain set of problems that sort of lend themselves to optimizations, and this is one such optimization that's commonly used. So I think it's used a lot because it's kind of hard to see it. It really trips people up. Like it caught me yesterday. It took me a while before I realized it. And the general approach to problem solving, and these problems, and really all problems, but particularly these interview questions, is that you really have there's like a very general approach, which is first you've got a naive solution, which is like some brute force backtracking shenanigans that you've got to do, and then you can quickly determine whether or not, depending on the input size and the problem, whether or not that's sufficient. If the input size is very large, then you've got to try something else. If the input size is then you know immediately you got to just do better than the naive algorithm. If it's still small input but a little too small, a little too big to be exponential time algorithm, then you know you're dealing with something a little more special, and there's a sort of a laundry list of optimizations you can apply to your problem that will speed up your algorithm dramatically. And one such optimization is using frequency keys, or rather frequency maps. So that's one of them, and it occurred to me that this problem, when you think about the problem a little bit more, you'll probably see which optimization you've got to apply. But it really boils down to, there's a whole series of different data structures you can apply and different sort of algorithms you can apply to quote unquote massage the data into something workable. One of these being, right, calculating the frequency of something. But in between, I'll even put this in another category. There is yet another category, which is the memoization if you're dealing with dynamic programming. So dynamic programming, for the most part, falls into simply writing a recursive brute force algorithm and then memoizing over the results of that algorithm, which gives you something, instead of being exponential time, it'll end up being polynomial time, the time complexity. And doing that is kind of makes a lot of the dynamic programming problems, which seem very difficult, that makes them kind of trivial. But that's a big optimization to look out for, is just, can you memoize these things? But yeah, this is one of the less, it definitely can trip you up, but it's a little easier to understand. Usually these problems are kind of easy if you need to use a frequency map. So I believe this is one such problem. I don't really have a proof exactly. I have had something inkling of a proof in my mind about why that would be the case. It has something to do with the fact that if you swap the balls around in these containers, I'm not going to read the problem here because I already did that in the other video, the other stream, but basically if you swap the balls around, you still have the same number of balls in, not even just in all of your containers, but whichever container you swapped a ball in, it still has the same number of balls. So every single container will always have the same number of balls, no matter how many operations you do, which implies that in order for a particular color to be possible in that container, and you can obviously swap containers around, right? It's not like you can sort of move colors and move containers around at will by just swapping things appropriately. So there's no real particular, the order doesn't really matter. So then what matters then is there a container with that begins with as many balls as there are a particular type? So in other words, if you have blue and green have 3 balls each, then you necessarily need to have containers that have at least, there has to be exactly 2 containers that have exactly 3 balls in them. That way you can swap in the blues and the greens into those containers. And I think that's an if and only if. So obviously, if you don't have that condition, then it won't be possible. But if it's possible to do what's asked in this problem, then that implies that, not being possible implies that somewhere along the line, there's a mismatch between these 2 hash maps, where there's either too many or too few balls in a particular container, and so there's no possible way to fit all of the balls of a certain type in that container. Yeah, that's it. I think that's it. Yeah. So let's see if we can code this up in Clojure. And I guess I mean, if the logic is correct, if it's sort of a formal proof, that's kind of how you got to approach these problems, and often, because testing is all well and good, but you cannot test everything. But a formal proof does cover all the cases. So in your mind, you kind of got to come up with a proof, which I think that's sufficient as described. Although part of me is still not really convinced. Still nervous to do it, but yeah. So what we're going to do is write and we're going to use Clojure because I'm learning Clojure. And what we're going to do is check our concurrent viewership here. Neato. This is kind of cool. Average watching 25 seconds. We're live, man. We're live. We're doing it. We're doing it. Yes. What it comes down to is with this frequency map. So how do we build this frequency map? What we're going to do is in the first pass, what do we want to do? We want to say, okay, iterate through all the containers, and, or really this is a matrix, right? So iterate through each row of the matrix to get the count of a particular, what's that called? A particular, well, let's see. Let's do it this way. So, oh, what's that? What happened? Is everything okay? Oh, I got my emails up. Oh, I forgot about that. Let me close that. Let's give me a second here. Yeah, I got all kinds of stuff open here. Nothing to be concerned about, but just stuff. So basically, the frequency. This is a pretty neat problem, kind of cool problem. But you're gonna say, okay, for each row, you're going to add up. You're going to add up all of the. Yeah, so you're going to do first by column and then by row. And like column, you're going to add up all of the containers. Let's see, this matrix, it doesn't really matter how you do it exactly. You can do it by row or column. And you just have a hash map that says, okay, so first you do it by row, then you do it by column, and you add up everything. If for a given row, add up all of the values in that row, and then similarly add up all the values in a particular column, right? Column by column, row by row. And what you're going to do is first you start with the rows, and you add to a hash map. You say, okay, for a given value, if it doesn't exist already in that hash map, make it 1, and if it does exist, increment it. And then when you do so that's by row, and then when you do by column, you subtract of the value that you see, right? If it doesn't exist, then make it -1, and if it does exist, then subtract 1. And then what you're going to do is check at the end that all of the values in the hash map are zeros. At the hash map is, it doesn't really matter. You don't have to check if it's empty. It won't be empty because n is non-zero. Well, if it's empty, I think you just return true. But then you're going to check that all of these are 0. All of those hash values at the end of it, or at the end of these operations, is 0. And that should be sufficient. So I think there's one more problem here, which is I think what is it? It's what is the problem? If it's empty, if the whole thing is empty, right? If n is 1, but m is 0, right? N is 1, m is 0, the whole thing is empty, then what's the problem? Yeah, 0 will be in the hash. Yeah, the hash map will never be empty. The frequency map will never be empty. Yeah, it's fine. Okay, so then yeah, you just check that whatever is all the values in the frequency map are 0. So all right, let's see if we can code this up in Clojure. It's interesting now. It's going to be interesting. So organizing containers function below. So we get this container, organizing containers, and what do? We got So we start with f pointer get system environment output path q integer parseInt Clojure string trim read line. So q do sequence q iteration range q. So this is going to tell you how many queries you have. That's the first q. And then it says, okay, you're going to iterate q times. Q iteration is going to be the, like, this is a binding. So it's going to be for, this is a sequence of values with 0, 1, and this will be a binding over that sequence. Yeah, so this actually represents the sequence. And then you're going to do sequence, which I guess this, I'm not familiar with this one. Do sequence. What does it do? Let's see. Executes a body. Bindings and filtering is provided by 4. Does not retain the head of the sequence, returns nil. So do sequence. So this would do the Cartesian product. This would sort of be a double for loop. Every x by every y. Do sequence print xy. This is like a 4, right? You could do, it's the same thing. So there's this XY binding on this do sequence. So the XY binding is going to be, what is this? Map list. Whoa, what's going on here? Map list 1, 2, 3, 1, 2, 3. This looks like I'm really confused by what this is doing, this binding. Map list is 1, 1, 2, 2, 3, 3. Is this, did he define this? What is this? What is this? I know what map does. List. But I would expect this to be, how does map work then? Clojure. Still kind of learning Clojure. Oh, I guess you could do, okay, multiple collections. So it does work, alright. So what this will do if you list, so it's going to apply list to both of these collections. Result of applying F to the set of first items. Oh, that's cool. So list is applied to these two, 1 and 1, 2 and 2, 3 and 3. So you end up with, oh, that's very interesting. Okay, I should know that. Actually, I think I should know that. And then you operate, you bind x, y for each of these, and then you print the multiplication of x and y. 1, 4, 9. Now, what is nil? That's kind of odd. Now, I wouldn't expect you to print nil at the end. I got the same thing here, nil. That I don't really understand. Why would it print a nil at the end? Huh. This also prints a nil. These all seem to print a nil for reasons that are not obvious to me. So it's like a 4, really, the do sequence. It's not really, it's really just like a 4 equivalent. It's like a, it's almost semantic, almost does exactly the same thing. What do they call that? It's like a synonym. Not sure why it's in there, but yeah, it's almost exactly the same. Sequence expressions, body expression, sequence expressions, and body. Maybe there's a few different expressions that get called here. List comprehension. So I suppose the deal is this naturally has a few different expressions that it will execute, whereas this is just one expression, body expression. But they're it's kind of yeah, really synonymous, because you can use a do expression to make this a body. Like, you know, it doesn't actually need to just be one expression that executes. So you could just do a for do, and that'll be a do sequence. It's the same thing. I guess that's why they put the do in there. Interesting. Anyway, kind of neat. Let me actually change the title to like in Clojure. Can I do that? HackerRank, medium. Mess around with Clojure. Like that. I like that. Yeah. Okay. So now we've got this F pointer gets this output path environment. Let's do sequence Q and parsent Clojure trim read line. Oh, I see. That's how we know where to output the output to. Do sequence Q iterator. So we iterate. So we have this sequence of over Q, right? And we say, okay, let n be. Now this is kind of interesting. This happens. You define this n. All right, that's fair. Define this symbol n as a parse the integer. Read the next line. Right, trim. Read the next line. So you get this value n. Got it. Makes sense. Then we have this container, and we say for each n, you're gonna say, oh, this is interesting. You don't need this line, I think, unless they don't use an initial. That's kind of interesting. So for each n, you have this. So this is a thing you'll see in Perl every now and then. So what will happen is, even though this is bound here, the Q iterator, because you have a do sequence, this Q iterator will represent each value in the range. Right, you're going to execute this whole thing on each value, and looks like we don't reference Q iterator anywhere here, so it doesn't really matter. And then here, do sequence range n. This is something from Perl. You'll see they use this symbol to represent the, what's that called? This symbol is something that you don't use, meaning it's kind of hard to express semantically because there's so many double negatives in there. But it's like normally you'd have a variable like A, and that would be like that would bind to each value in this range, and you would use A. But this underscore, it means that you're still using the same syntax, and the variable still gets set. So this underscore could be used in the code, but the underscore itself indicates to the person reading the code that even though you could use this, we're going to use an underscore to represent that you're not actually going to use this value, even though it's going to get set to each of the values of n. And that's something you'll see in Perl code, which is kind of unusual, kind of interesting. So anyway, so that's what this is. So this says, okay, so for each, this is basically like saying for each n, do some stuff. And particularly what it does is defines container again. So it actually overwrites this one. And that's so strange. Oh, excuse me. I take that back. It doesn't overwrite this. No, it does. It overwrites this. It looks like it conjugates itself. Okay, I see. So this is going to be a vector of vectors, if that makes sense. Okay, I understand now. So what's going to happen is for each n, you're going to do what? You've got this container, and you have this conjugation of the container with a vector of a map of, this is an anonymous function, which is going to be the integer parseInt, right? So you're going to parse an integer, map that to, oh, I see, yeah, because it's all in one line, right? For some reason I was thinking this is going to happen differently, but because it's all in one line, you can just split the string. You can first read the line, then Clojure string split using a single space, right? And this is a macro to, I think, specify that's a literal. Go look at the Clojure reader. So I'm still kind of learning Clojure, but this is kind of cool. This is why you do this, right? You can really understand dispatch. The dispatch macro, okay. So this sets regex pattern. Yeah. So this will be a regex pattern. Okay. Right. That's interesting. Anonymous function, it could be a var quote, which basically gets converted here. It could be an anonymous function. You could ignore the next form. Yeah, kind of cool. But this one, I'll probably end up memorizing this one. 1, 2, 3, 4, 5. There's 5 different meanings depending on the context. It's kind of wild, but you'll kind of remember it after a while, I think. So it's actually being used as a regular expression to split the next line on. And so we split that, create a, I guess you would get probably, let's see, Clojure string split. And Clojure string split. I think what you end up with is a regular expression. Optional argument limit is the maximum number of splits. Not lazy returns a vector of the splits. Okay, so you get a vector at the end of it. Splits, just like in Python. So this vector, you then map parsing integer. You see, parse integers out of the vector, resultant vector. And the problem with that, though, is I think map returns what? I don't think it's a vector. I think that's why. You get a sequence. You get a list. I think you get a list. So you convert that back to a vector, and then you conjugate this container, this collection, with that new vector. So now this is a vector to begin with, and now that you've conjugated this with this vector, you've effectively added a vector to that vector, right? And then that becomes the new container. So that's what happens. That's kind of interesting. Yeah, Clojure is very terse, Very neat, very cool. Really like it. Functional, man, functional. So now you have this container with a whole bunch of, you're redefining this symbol each time. Which I'm actually not sure if that's the right way to do it. I'm kind of uncertain about that. Like, what's the Clojure way to Clojure append to vector, something like that. Conj. Kind of curious what other people think of this. The problem is, while you can redefine the container to the one with the new conjugation, I'm wondering if this like breaks any rules or sort of creates side effects, something like that. Kind of conflicted about this one here. Like, why not? Interesting. Kind of wonder what other people have to say about this. Hold on. I'm looking for examples. Can I see? Yeah, I want to use like an association. Although this seems to be like from maps for the most part. I wonder, do you really need to? I guess you do need to redefine it each time if you do it this way. It's kind of like, I don't know, man. Conflicted about this here. Let's think about this. Let's think about this. Like, I'm wondering if this creates like side effects or something. That's kind of what I'm thinking about here. Like, if this is a better way to do this, correct way to do this. Because, container. I don't know, man. Anything that was referring to this object before, it still would be referring to the same object, the correct object. It's just anything that uses container after these lines. See, that's the thing. I'm kind of, because it's almost like you're using this as a pointer, this definition, which I don't know. Redefining a symbol. Like, is this not? I don't know. I'm conflicted, man. I saw this and I just it threw me through. Let's just say it threw me through a loop. How can we do this otherwise? You know you can, I know how to do this otherwise. I know exactly what to do. I know what to do. How about this? We can bind the container to this I want to do something like this, like you have into here, and then you can say there's this sequence. How? Like why not this? How do we do this? Like let container be this, right? And then you can say here you can have this do sequence, and what you're going to do is instead of redefining container, you can say into container or just conj container. Yeah, just like this. I don't know, does that work? What happens if we do this? And there's spit. Nice. Spit, it's called. Clojure. Clojure spit to standard out. So can we print line, Clojure print line? Is this thing on? And then also print line of, now does let have multiple expressions? Okay, so we can just put everything here in a single let. Forget the into, we don't need that anymore. Is this thing on? Print line, container, and then define result, and spit this result. Alright, what happens if we do this? Let's just print line, nothing done. I just want to know what happens here. Wrong answer, that's fine. Compiler message. It's my output, standard out. 1, 2, 3. Debug output, okay. That's what we want. Is this thing on, nothing done, is this thing on, nothing done. Okay. And because container, so yes, the issue becomes we bound, we rebind. I mean, is that what it does if you rebind this def? You could say rebind container to this conjugation. Is that what we want? Because you can use a looping structure here too as well. Oh really? Wow. Huh. So maybe you do need to just redefine container in this way. Huh. Say it ain't so. Say it ain't so. Oh, runtime exception. Whoa. I don't know what happened there, but we got 1-1. Interesting. Wow. Very interesting. Oh. Could also have something to do with that as well. Oh no, that's why. Okay, I think I see the problem. Okay, that might have something to do with it. Messed up the parentheses here. Oh no, wait, what? What? You're kidding. Really? No? What? What? Redefine container, yeah, I guess. Wow. That kind of sucks. I don't know how to do this. There's, you could do, I think part of the difference between the for and do sequence is that the for will actually create a collection at the end, whereas the do sequence does not necessarily create a collection. And I'm wondering if we want to say, if we want to use a list comprehension like a for. So we could maybe do this. If we say, if we go here, container is going to be this for, and yeah, we can use the sequence of these values. Or, it's going to get kind of confusing. There's a lot of bindings going on here. But container is going to be the bound to the result of this. And the resulting collection is going to be actually it's not container, it's containers. So we can do this container like so. Why are we doing this? Why are we making this hard for ourselves? We could get the code that actually gets the container here, right? We don't need this conj container. We can just do vector map integer parseInt Clojure split read line, right? That's what we define this guy to be. Could even, I like doing this though. This is kind of just my style. Do it this way. It's a little clearer. Don't need to do it on every line, but some of the lines, depending on how verbose the thing is. Yeah, I like doing it this way. And then, so now we have a way to get a container, right? To get the next container. And then what we want is we're gonna let containers be, print the containers, say this thing on, print containers, and we're gonna say for this value in this range, we're going to create this vector of container. And that's going to be let containers be the result of this for the resulting collection here. And you could even make this a, yeah, print containers, let containers be this, right? And let has a series of expressions. So I probably won't do this every time in the future, but I'm just kind of thinking, how would I do this? Given that I just spent like a ton of time in the Clojure docs documentation. So I'd probably do it this way. You bind containers to the result of this for expression, which would be you're looping over all the values in this range and then getting a container. Now that you don't really even care about this value. And then this is going to end up pushed into a collection, which I think is a list, which means I probably want to put a vector at the end here, but I want to see what this prints out. See if this even works. And this should be containers, not container. We'll see how this goes. Compiler has an error. Yeah, there we go, 1111. You see that? Now it's not quite what I was expecting. Is this thing on? Thing, that question. Nothing done, should happen twice, right? No, just once. And is this thing on? It gets called once. Oh, time for bed. And then print containers, we get 1111. And that's kind of a, oh, interesting. There's kind of a lot going on there, huh? I think the problem is that this gets executed and you get QN. Yeah, I think that's the problem. I think this read line actually gets executed here. Right, if n gets executed, this isn't just a function that you can call. This actually happens immediately, this read line. Which is kind of awkward. Shucks, man. shucks. Maybe we can define a function. Maybe define n is not what we want, but we want define function. Why is that not supported by there? It doesn't show up as the macro. Wrong answer. Okay, got it. But no response on standard out. Holy guacamole, man. It's giving me such a hard time. Does it not have this macro? No, it's right here. Could put this define n over here. What does this look like? Super curious, you know, just kind of poking around at this thing. I'm not sure. Oh, you know what? I think this is the problem. At least one of the problems. Oh, this is correct. That's kind of funny though. There we go. That's what we want. What does that do? Wrong answer. Wow. No comprende. Where's the part that's struggling here? What's the part that's like not compiling? It's the thing I'm confused about. Oh. That might have something to do with it. Let's see. What is this exception? What is this? Did not conform to spec. Because I don't have a spec in there? Problems. So defining this function, I think, had an issue. Really? What does define n look like? Oh, I think that's why, because you need an argument list, which doesn't have an argument list. Defining the arguments for the function. Oh, there we go. Okay. So, all right. Fine. Okay. Excuse me. So, and got containers. Call the function container, which gives you this vector, and then you get this collection. Now, what does this look like? So that was the issue. The macro didn't line up nicely. Okay, 110211. Now that is a little bit better. But now the thing that's throwing me off is, why does it say 1111 again, and then 0211? That is super confusing. Oh, because these input the sample cases. It says 11110211. Oh, of course, that's why. Duh. Oh, it does work. Okay. Oh man. Okay. That confused me. All right. That makes a lot more sense now. And finally, you can say create a vector out of this. And then you can continue. You have containers. Cool. I'd probably do something like this. All right, 11110211. Yeah, I'd probably do something like this rather than what they had. And the reason is that they're redefining this container variable over and over, and it's kind of, I don't know, kind of question that, I guess. Whereas you can create this function and then call this function repeatedly in a loop. Use a list comprehension and create vectors out of that, and then define your containers to be that. Just bind that here, and then operate with that binding. I like that better. I like that a lot better. I don't really like having this like intermediate symbols, because it kind of gives me this idea of like the whole purpose of Clojure, the whole impetus is to have things not be to make things immutable, and it's kind of like you're mutating the container object when you, or the containers vector, when you sort of continuously redefine the symbol. It's kind of like mutating it. It's not really. It's actually what it's doing is it's actually like deleting the previous version of it and then rebinding the new version each time. Like each time you redefining the symbol. But it's like redefining the symbol repeatedly, which is kind of awkward if you're using the symbol elsewhere, you know? That's why I'm kind of like, it doesn't seem the right way to do it. Yeah. Like I'm thinking if you're doing this in some kind of multi-threaded fashion, may not be the right way to do it, I guess. Yeah. I don't know. I don't exactly know. How would you do this in a kind of can't really do this in a multi-threaded way, because you're reading the lines. Like reading the lines out of order doesn't really make sense. So you kind of can't. Somewhat can't. I guess. Anyway, I don't know. I was just thinking about it. It just doesn't seem right. Didn't seem right. I probably won't do the similar shenanigans again in the future with these kinds of problems, because this is sort of boilerplate code that they provide. But I was like, I'm still kind of learning Clojure and finagling. It's kind of useful to go through these kinds of exercises. Okay, anyway, so you get this result of organized containers, this function call. And so what I was suggesting, in order to actually solve the problem, is you have a frequency map. Now, there's hash maps in Clojure, and then there's also associations in Clojure. And what you're going to want to do is, all right, so this is going to actually add to the map. Return a new map of the same type, contains the mapping of keys to values. Returns a new vector that contains value at the index. Right, so this is key and a value. Apply to vector. So we're going to create a map. This is going to be interesting. So we're going to create this couple hash maps. We're going to say define it's going to be ball frequency, and that's going to be hash map, or even just this thing. Right, that's also hash map. And then we're going to define, it's going to be container size frequency. All right. We're going to say ball number frequency and the container size frequency. And then we're going to say, now here's the tricky part. Clojure add to hash map with default. So I think this is the way to do it. Merge. Okay, it's not really a merge. Oh, okay. No. Can you associate with a default value? Not really, no. So there's map, key, and then not found. Okay, that's what we want. So what we want to do is say, all right, we're going to get. So first things first, we have operate over for loops, or operate over the rows, operate over the columns. So we're going to do something like interesting. Can also just give. What are we doing here? I'm thinking we can do like a couple things. We can get the container size in a number of ways. I think we need a container size though to do this loop that we want to do in this particular vector. Excuse me. Can we get the size of the vector? Is that possible? Count, I think. What's the time complexity for this? Clojure. Implementation is here in Java. Interesting. Okay, sufficient. So we can do size. All right. So we're gonna do size of container. That's containers really. Size of containers, and we can say use a list comprehension of range. Actually, we'll say X, and this is going to be. Now, do we want a collection here? Now, what we want to do is, how's this going to work? It's going to be, got this ball num frequency, got this container size frequency, and we can say, really it's a double for loop, right? It's for how do we do this? Could use do sequence. I think that's kind of not what we want to do though. Seems kind of bad. It doesn't seem very Clojurian to use do sequence like for loops. But we can do, let's see. This is why you do exercises like this, so you get more familiar with the language. We can do, fix our syntax here. What do we want to do though? This binding, it's a range of values. Because this list comprehension would give us a whole, give us a collection of things. It's not necessarily what we want. Collections, not really what we want. What we want is actually to operate on, so there is a difference between do sequence and for. That's good too, but loop is really what we want, I think. And then we also want do sequence. Yeah, what's the difference? And then also, yeah, do sequence executes side effects and returns nil. I don't want side effects though, so I don't want to use do sequence. For builds a sequence and returns it, which is very different. Yeah, that's what I was thinking. Loop. Yeah, this is probably more what we want. I like this more. I don't really want to do a, I don't want to have side effects, I want to avoid side effects as much as possible. Right, so let's do a loop. So the way a loop works, it's kind of neat. You have, so I'll explain. So the way a loop works, you bind, the loop is pretty neat in Clojure. You bind, still playbacks. Interesting. Okay. It's gonna be kind of a long video, I guess. But what you end up with is, yeah, the way a loop works is you have some argument, right? An initial binding. And then when you recur, you provide the new value for this to be bound. So what we want to do is, and we also want to provide, like, a way to break the loop. So we use an if statement, which is basically if condition, then break, otherwise recur, and we probably want sort of a let do kind of thing going on here. So we can say loop range size containers. It's not really what we want. We want, I guess initially it would be 0, and then we want to recur with increment x, right? So it'll rebind x to the increment of x, and we want to break if, I could do the other way around. Well, yeah, I could do it this way. If x is less than size of containers, right? So this is going to loop through all the containers. If x is less than the size of these containers, will recur. Yeah. And then we can have like a let in here, which come back to that later, I guess. So what do we want to do? We'll do the ball number frequency first. So I have this loop. It's going to loop through the containers. And that would mean rows. The thing I'm wondering is we can say let val be the sum over, I guess because this is a vector, right? So it'd be, how do we access a vector in Clojure? Vector of get nth peak association pop subvector replace. See some examples. Vector 1, 2, 3, 1, 2, 3. So you can, yes, data destructuring, which is fine. But what if we want to just access the vector? Okay, nth get. You can get as well. Nth or get. Nth collection index, get collection index. Alright, so you can just use get again. You can just use get. Okay, so if we get from containers x, then we summate over those values and bind that to val, then we can say, and obviously we'll recur afterwards. I don't think this if, so we can do it, use a do. I think this is if Clojure. Use a do. If let, if not, when let. I think this then, I'm wondering if it could be multiple expressions or if it's got to be do. I wonder if it's got to be a do. Doesn't really say anything here. I think I saw it somewhere in the docs, but yeah, well, I can maybe test this. All right, what happens here? If we do this, use really size. Couldn't find size. That's interesting. I think it's not size, it's count. That's probably why. Oh, still. Oh, vector to number. Okay, gotcha. I gotta destructure this thing or reduce. Yeah, that's really what you need. So reduce over the. Okay, cool. Test. Test. So let. Now what's interesting is count of containers. Huh. Okay. X is less than count containers. Then this happens. I want to say this also happens, but I get the feeling like this is never called. Huh. I mean, I could put it in the let. The let actually has. Doesn't really matter. The let has multiple expressions, so I can also do if let. Just a more compact version of the same thing here. There we go. That gives us lots of values. Let's go with. That's kind of cool. We can loop over the number of containers. We can let value be a reduction over the. Now the interesting part is We're going to recur on increment fx, right? So it's going to go through all of the containers and update our ball num frequency map. And now the interesting part is we want to rebind. See, that's the part that I'm interested in this loop. We have bindings, right? Right. It's not even the ball num frequency. It's going to be So this is the part that's kind of interesting. I want to update this ball num frequency and this container size frequency. I want to update these two hash maps. So this is where Clojure being persistent and immutable gets kind of, we'll just say interesting. Gets a lot more difficult than other languages. Other languages would be really straightforward, but here we can use side effects and redefine these symbols, but I think that's not the right way to do it. I don't really know. I'm a little conflicted about that. What I want to do, I mean, maybe that is the right thing to do. Because what you end up with is like, define these two here, right? What you end up with is well, you rebind, I guess. You just rebind. So instead of test, you're going to say get container. You're going to get from containers of X, right? And you can actually do two things here. You can put this on a new line and say container, right? Get containers of X in that container, and then you can say I don't really like that. That's a little bit better. Okay, that's fine, I think. Get containers of X, reduce over this container for the value. And this actually is going to be balls. And so now you don't need to get this anymore. You can just use container. And you want to say from the container, you're going to, it's not really containers. You're going to get from the ball num frequency from this hash map. You're going to get the balls, or or num balls. And if you don't find it, the default is going to be a 1. And then you're going to associate with the ball num frequency this new value. And you're going to redefine it. Yeah, that's the tricky thing. That's the interesting part. And that should give you this. Holy smokes, that took a while to code. Holy guacamole, man. Really unusual, I think, for most people programming something like this. Oh, it just flat. Exception. Didn't compile. Arity. Which one's incorrect? The arity. I don't know. I don't know which one's which. Is it this? Seems to be. Okay. Oh, the association is going to be, you need to add this pair. So you can say association, or maybe it's better to do like this. Yeah, it's better. And what you want is this value. And it's going to be with what key? Right. So if it's in there, then you get whatever frequency it is. Otherwise, right, okay, so it's got to be a 0, otherwise you get a 0, and then you increment this by 1. And that's what you associate with this map, this new map. And we can do a let also, new val, would be this thing here. Or just new pair, or what do they call that? New key val, or new KV. I like that better. To this thing. Yeah, I like that. That's good. So you bind this map to this thing, and then you say let new key value be this numballs with increment get from the ball num frequency, the number of the balls, number of balls, 0 if you don't find it, increment that value to a 1, and then so you'll either get a 1 or the value that's there plus 1, bind that to new key value, and then associate this new key value with ball num frequency, and then you want to redefine this ball num frequency, and then you recur here, and that ought to do it. This part we get rid of. Yeah, that seems to be what we want. Let's see if that compiles. Wow, learning a new language is, I mean, I guess it makes sense, but it's going to take a while before you really get comfortable. Wrong number of args passed to association. How does the association work? Also need to sleep. I need to sleep. Map key value. Oh. Shucks. I did it wrong. It's actually got to be key numVols value, which is this increment. I don't know, I'm kind of conflicted about putting a tab here. I think putting on a new line is better. Yeah, tab looks weird. Okay, let's try that. So you can do key value, and then you can do key value. Okay, how about that? Gotta get used to this, man. Okay, wrong answer. 2-2. All right, got it. So the ball number frequency, we get 2 balls here twice. Possible, impossible. I think this is wrong. Possible, impossible. The container has type 1. Type 1, type 1. Or as one of type 0 and one of type 1 in the same container. Oh, yeah, okay, no, it is possible then. So count the number of balls. And we got 2 and 2. Total number of those 0 balls and the total number of balls in the first container. Now it's supposed to be so we see 2 containers with 2 balls in it. That's what this means at the end of it here. Now we could do the container size frequency as well. So actually that's what this one is. It's not the ball number frequency, it's the container size frequency. Yeah, so yeah. Now the thing that's interesting is we could say there's a few things that could be done. I'm thinking about like maybe writing a function that could define these two. Oh, never mind. I don't know. Not really sure. Like, in theory, you could write a function that does this counting. Man, this is so different from what I normally do. Wow, it's kind of wild. Oh my goodness. There's another thing too. This feels like I'm doing something with what do they call that? With oh my goodness, there's so many things to consider here. For starters, this feels like I've got side effects doing this. That's one thing. The other thing is I I still need another loop for the other hash map. So do the same thing again, I guess. Interesting. I don't know. Let's suppose for a moment we leave it with the, so we got a few issues to address here. One is, how do we do this without side effects? Whatever that means, because I feel like this doesn't really change the do sequence structure. Can we do like a loop without side effects? Clojure. Yeah. There's got to be side effects, unfortunately. So unfortunately, we're going to have side effects. That's the, I guess, the bottom line here. I definitely question it. How do we avoid side effects? How do we... So I guess do sequence is probably better than this whole looping construct that I created. But we can do a similar thing. So this is just, you know, use side effects to accumulate container sizes. Let's do this like a really kind of silly way, because I kind of want to go to sleep. We'll clean this up later, I think. Accumulate frequencies. And this is going to be accumulate vol type total vol number frequencies per type. All right. Total ball. Total ball count frequencies. Total ball, yeah. So we'll do something similar. This is not going to be for, well, it could be containers again, count containers. And then let, it's not going to be the container anymore, it's going to be type or ball type. And then we say number of balls, get containers of X. It's not going to be containers of X, it's going to be, the ball type is going to be X. This is going to be interesting here. It's going to be, yeah, it's not going to be the container. It's going to be, how does that work? How does this work? It's It's the other way around now. It's containers. It's what do we call it? What are we doing here? It's kind of interesting because we're looking at the ith element of every container. It's more like we can get a we can use a lambda expression for this, and not a lambda expression, but a what do they call that? We can use a list comprehension for this one. So we have this container. We'll use a list comprehension now. So we'll do for, and it's going to be get containers of. It's going to go like this. Reduce for get. Watch this now. The way this is going to work is list comprehension. It's going to go for I in range of count of containers, right? N is the same. Could actually be, all right, we'll do it this way even. No, it's, oh man. This is like kind of crazy. What are we doing here? What we want is, there's get containers of I, and then we want to get from there, get X, right? Containers of I, and then get X from I, and then we want to summate all of those values to reduce addition over 0, and that gives you the number of balls of that particular type. Yeah, but the problem here is this count is, it actually is the number of containers. Well, the thing is, it's going to be the number of containers each time. But if you were to do this as sort of m by n instead of n by n, but an m or n by m, there is another way to approach this, which is a bit different. You wouldn't use containers. You'd use like you would get the container of I, and then get that size. I think count. Yeah, you would like. That's why I wanted to use a let. Like let this be containers of I. But you can't do it that way. You need. I don't know. I'm not sure how exactly I would do it. I think I would need to somehow get the value. But for now, we'll just put count containers. But there's a way to do it. It would be. Actually, it would actually just be the number of containers. I'm not sure. We'll just leave it as it is. I'm not gonna worry about it for now. come back to that another time, I guess. But yeah, so let num balls be this reduction, and then let this now actually, since these are like right next to each other, you can put this right in here. Say, put this binding right in here, and say the key is going to be the number of balls, and the value is going to be the increment of get not container size frequency, but the other one, which is ball num frequency. And then you're going to say the number of balls, and if you don't find that value anywhere, that key, then you're going to get 0 and increment it. If you do find it, you increment it anyway. And then you're going to say, I've already got the same let in here, which let also does multiple expressions, so we can just define and recur. And so what we're going to say is your ball num frequency gets redefined to be the association of this ball num frequency, this key value. And so that'll do your, for each row and for each column, you count the frequencies of the summations, and then print these two. Ball num frequency with the other one, it's container size frequency. Alright, and finally we want to say our function will return ball num frequency equals container size frequency. And I'm not sure if this works the way that I would like it to, but we'll find out. We'll find out shortly. So it does not work the way we're expecting. Okay. True false. Debug output 22113122. Where's that debug output coming from? Am I printing things? Oh yeah. Okay. Oh yeah, cool. So we had 2 and 2, which we expect, right? We get 1, 1, 1, 1. So one of these is the containers that have 2 balls in them, so that's 2 of them has to have 2. It's the first 2, 2. The other one is how many balls total do we have for each type of ball? Like I count the frequencies of the amounts of the total. So we have type 1, we have type 0, we have 2 of them, right? So that's 2, 1, and then type 1 we have 2 of them. That's 2, 2. So you see 2, 2, 2, 2. The next one we have the number of balls is, right, we'll do that one first, is 0 of, or 1 of type 0, and then 3 of type 1, right? 1 of type, or 1 of type 1 rather, and 3 of, and 1 of type 3. Yeah, and then we have, wait, I did it right, the ball number frequency and the container size frequency. Yes, right. So the container size frequency, both these containers have 2, but the ball number is there's 3 of these balls and 1 of these balls. So these are not equal to each other. It's got true, false. So we really want possible, impossible. If it's true, false, we can, yeah, I could just say, you know, so if, so we'll say if, so we can say let check, Actually, let's do it this way. Organizing containers, question mark. All right. So that's done. And then we'll say find result bool. Now we're going to say result to be if result bool, then what do we say? Possible, impossible, possible, or impossible. Okay, how about that? How about that? Nice, got him. Get rid of this debug output. And I would be willing to bet that this is correct on a lot of test cases. YOLO. Hey, got him. Cool. Very cool. Yeah, it's a neat little problem. So I had the solution. If I was doing this in Python, it would have been very quick. Okay, we had one viewer a while ago. Interesting. Yeah, so pretty interesting. Not really sure what to do about these side effects. Also not really sure. So there's a few ways to approach this problem. One of the things, by the way, is we can use a single hash map, and we can do these sort of in tandem, these loops. And what we can do is compute this number of balls, right? You know, combine this here and here and get this value. And also combine this let to get these key value. Can even just call this a key, combine all this, just have one key, and then use this key here to get this value, have the key value, and then what we can do is one of these would be 0 in increment, and the other one would be 0 in decrement. And instead of checking if these are equal, you would check if the value set is all 0. All right, and you could do that in a single. You can do that in a single loop. And further, instead of the thing is, you have this definition that keeps popping up, this sort of side effect that occurs. I think what you'd want to do is actually just rebind up top here that hash map, which I guess is kind of what you're doing here. I don't know if this is technically a side effect. I'm kind of uncertain about all that. Loop side effects. This is something I was kind of afraid of, like getting into this. If the whole purpose of functional programming is to avoid side effects, how do I actually do that when sometimes it seems like you need it? See, this I kind of like. Yeah, I'm thinking looping would be fine. If you just rebind the argument. The problem though is you still have an issue of, like, you rebind the argument, but you don't ever get, like, you still have to do this check at the end that like, okay, the whole hash map is 0 after all the computation occurs, and you actually need the state of you actually need your hash map at the end of it all. You actually need this thing, this defined, something defined, the symbol defined, to actually get it and make use of it after all of this. So I don't know, this is kind of not, I don't think this is really functional programming per se. I don't really know, I'm still kind of uncertain. Like, how would you do this functionally, this solution? I don't know, I'm conflicted about it, certainly conflicted. It's kind of cool, but yeah, I don't know. I don't know. How could I make this function just purely functional? Very interesting question. It has side effects. I don't know. I have to really think about it, how this can be done. Well, anyway, I'll ponder that some more when I go to bed. But this is an interesting problem. I'm grateful for this, and yeah, thank you all for hanging out, watching, saying hello. I don't think, did anyone say hello? I don't think anyone actually said hello. Anyone who watched, I appreciate it, and talk to you all soon. I don't know, I think tomorrow I may tinker some more with Clojure, and I think there's some interviewing to get ready for, some things to do. Yeah, man, I don't know, I'm like, you know, how do I program in Clojure realistically? How do I do it? I appreciate the persistent data structures, but I'm still going to struggle with not having side effects in my code, which is kind of one of the points of Clojure, is to not have too many side effects. Keep it to a minimum. So yeah, have a good rest of your night, good rest of your day. Take care.